Hello everyone, Gurudev NEET Academy welcomes you all. Here in the series of some important topic, we are just likely to discuss Pinacol Pinacolone Rearrangement today, right? It's a very important organic reaction. Actually, in this reaction, Pinacol Pinacolone Rearrangement. This topic is actually equally important for JEE and NEET. What this reaction is? Actually, in this reaction, 2 moles of acetone is treated with the magnesium amalgam in the presence of mineral acid, which is used as a reduction process, and finally treated with H2SO4 to get a ketone. This whole reaction is called Pinacol Pinacolone Rearrangement. What actually we do, just see, 2 moles, we take 2 moles of acetone in this reaction and it is being treated with magnesium amalgam, that is mercury, followed by reduction to give you a pinacol, CH3, then one more carbon and CH3, and at this 2 carbon we are having 2 OH, right? Now when this pinacol, this is actually pinacol, when it is treated with H2SO4, one of the OH, either this one or this one, depending on the nature of a carbocation formed in the reaction, either of both being removed, right? And migration of methyl take place. From here to here, wherever we are just carrying out. Actually, I am writing the product, then I will explain the mechanism. This is the pinacolone, sorry. Actually, this is not a named reaction, right? Pinacol, this structure is called pinacol, having 2 OH and ketone with the tertiary butyl part, or rather better to say tertiary carbon, is called pinacolone, right? Let us see how the mechanism of this reaction being proceed. Mechanism. Just see, you have to write ketone by this way. CH3, C doubly bonded O, CH3 plus one more mole of ketone by this way. Okay, what happens here? This bond cleaves homolytically, forming free radical here, free radical here, free radical here, free radical here. Now carbon-carbon free radical get joined together, right? So see by this way, CH3, C, CH3, this carbon is joined with another carbonyl carbon, CH3, oxygen, oxygen. Actually homolytically being cleaved, so one dot will be there over the both oxygen, right? Now what happens here? Magnesium actually goes into Mg2 plus via loss of 2 electron, right? So 1 electron is taken up by this one and 1 electron is taken up by this one, leaving behind the formation of leaving behind the formation of pinacolone ion, pinacol ion, O minus, and here again O minus. Now hydrogen saturate this one to give this pinacol. Now this become OH and this also become OH. So this is how the pinacol being formed, right? Now let us see how this pinacol being converted into the pinacolone, right? So we are having on the next page. So this is the pinacol which we have formed previously. Here is the OH and CH3, CH3, OH, right? What happens actually? H2SO4 ionized to give H plus. So H plus attacks either of this OH group, right? So let us say it attacks here because this is the symmetrical pinacol, so we don't have any problem to attach this hydrogen at either of OH. But the problem arises when this pinacol is unsymmetrical, having 4 different substituents, rather better to say the chiral one, right? In that case, we will talk how the H plus is coming to OH later on. First, let us take the simple case. So this is now going to form OH2, and you know OH2 is a better leaving group, so it will leave the site, leaving behind the formation of a carbocation here, okay? So C, and this is CH3, CH3 and carbocation. By loss of OH2 from here, OH2 means H2O lost and this carbocation is formed. Now from the NT position to this carbocation, methyl migrates. This methyl migrates here. Okay. So leaving behind the CH3, this CH3 have been migrated. This CH3 have been migrated, right? So if it has been migrated, so positive charge will be here, and this now branched, right? Now HSO4 in the first step, H2SO4, H plus came from H2SO4, now HSO4 conjugate base being left. So this conjugate base will come to abstract this proton by this way. So leaving behind minus here, plus at the adjacent carbon we are already having. So here the H2SO4 is regenerated, but we are getting our product CH3, C doubly bonded O, and CH3, 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 right? So this is the simplest pinacolone. Okay. Some of the important point regarding this rearrangement is that in the first step, the formation of OH2 will take place at that carbon from which the loss of water molecule is going to produce the more stable carbocation, right? And the migrating aptitude of these substituents at the OH group follow the order AR greater than hydrogen greater than alkyl. This is the migrating aptitude of the different substituent attached either at this carbon or this carbon. Suppose here methyl, here phenyl. So which one you will migrate? Phenyl. Getting? We will take some example, so it will be more clear. Now, in the case of substituted aryl, the migrating aptitude follow the order OME. This one most likely to migrate first, then methyl, then benzene itself means phenyl, then minus I such as NO2 phenyl. So these are the migrating aptitude, these are the migrating aptitude: methoxyphenyl, methylphenyl, phenyl itself, and nitrophenyl. These are the migrating aptitude for the substituted phenyl, right? Now we will take some examples. Just see, we are having phenyl CCH3 OH C phenyl OH, right? And on the arrow it is given H2SO4 only, right? So how the pinocol will form here? Which one the H plus will attack at which OH? This one or this one? See here, this is the phenyl methyl means what I mean to say, tertiary carbocation having one phenyl, and this is tertiary carbon having two phenyl. So in this case more resonance stabilization is there. In this case more resonance stabilization is there. It means if H plus attacks here and by losing H2O, this is going to give you the most stable carbocation as compared to this two, right? So definitely in this case you will attack the H plus right at this OH. So what you are having? PHCCH3, right? And this OH will remain as it is, and here you are having PH and plus. Now see, either a methyl or phenyl migrate here at the C plus, right? So as per the sequence which I have just given, the migrating aptitude, aryl first, then hydrogen, then alkyl. So it is in the previous case. Here look, it is aryl, it is alkyl. So this one is going to migrate. So this will cleave by this way and comes here, right? So what happens in the next step? Just see, this CH3, right? And OH, and positive charge is developed here because this bond cleaves by this way, and phenyl comes here because of this rearrangement. Now see, HSO4 will come into the rescue operation to abstract this proton. So proton will always release as H plus. So H plus is taken up by this one. So minus H2SO4 will be there, and by cleaving this way negative comes here. So negative charge and positive charge makes a double bond. So here you are having CH3 C doubly bonded O and this 3 phenyl here. So this is the pinocol in this case we are having, right? I'll take one more example in which phenyl itself being substituted, right? Here we are having NO2, here we are having Cl, and here we are having OH, and here we are having phenyl, here again we are having phenyl, and here again OH. Now the question arises in the first step, H plus is to come. So H plus you will bring at this oxygen or this oxygen, where? You are confused? So don't be confused, H plus will come here because these are the minus I, minus M what happens actually, if the carbocation is formed here, these are going to destabilize that carbocation. While on account of resonance, if the carbocation is formed here, that is being stabilized. Actually, you can see this is the secondary benzylic carbon. So definitely the H plus will come here, and after losing H2O, what you are having? NO2 C Cl phenyl, one more phenyl plus here and OH, right? Now either of this or this has to be migrate. Getting? So the substituent causing greater minus I will not be migrate, causing lower minus I. So this is going to be migrate here. Okay? So this one going to be migrate and comes here as per the migrating aptitude being concerned. So this is C, and this is NO2, and here loss of water, loss of H plus is going to give this ketone. Okay, and at this carbon two phenyls are already there. At this carbon two phenyls are already there, and this one came via migration. So this is the final product. This is the final pinacolone, right? This is the final pinacolone. Getting? Let's have one more example. Suppose you are having this type of pinacol, methyl here, OH here, and one more OH here, and you have to write the product for this one. Okay. So again the problem arises, H plus will attack here or here. So look everyone, H plus will come here or here, that is decided just considering the charge here. Okay, if H plus attacks here, leaving by H2O, loss of H2O will provide the positive charge here. If positive charge here, so 2 alpha carbon, total 4 hyperconjugates are possible for this carbocation if being formed. Let us see the same here. If H2 loss right from this OH, so plus charge will be there. So here 1 hydrogen, alpha hydrogen, here 2 alpha hydrogen. So this ring going to give you 3 hyperconjugates, while this one going to give you 4 number of hyperconjugates. Getting? So definitely you will attack H plus at this OH, right? And by the loss of water, what you are likely to have, just see. Here it is methyl, here it is again methyl, and this is OH, but this is plus, right? Now see, H plus is to lost right from here, so that we could have a double bond in between this carbon and oxygen. So we have to cleave this bond by this way. Means ring expansion is now going to take place. This bond cleaves by this way, so negative will appear here, and this negative interact with this positive to expand the ring. So what you are having in the next step, just see, you are having this one, here it is methyl, right, and here it is methyl, and here it is OH, and positive charge will be there. So now this H plus will be lost by HSO4 minus to give you this one. Now this 5-membered ring becomes 6-membered. Just see how. From this carbon I am just attaching this one. Here it is the methyl, and just to this spirocarbon, next one you are having O, so here will be ketone. Now next to this carbon, just see, next to this spirocarbon you are having methyl, so this is methyl, right? Now what will be the IUPAC name of this one? Just see, 1, 2, 3, actually counting is start from smaller ring, 4, 5, 6, 7, 8, 9, 10. So just see, you will write spiro. In this carbon, how many, excluding this spirocarbon, how many carbons are there? 5. So we write in the descending order, 4, 5, spiro 4, 5, then at 2 and 10 you are having methyl, so you will write 2, 10 dimethyl. Total carbon is how much? Just see, 4, 5, 9 plus 1, because this one is not counted. So you will write decanone, decane 6 on, decane 6 on. So this is the name for this organic molecule, right? Now can you tell me the product for this one? It has been asked in JEE. pH, OH, EH plus. Can you tell me the product? Just see, this will protonate either of this OH, and one of the pH will migrate here. So definitely for the product for this one will be if attack here, so both phenyl will be there at the same carbon. So this is the product. For this reaction, this is going to be your product. Migration, if H plus attacks here, OH2 loss plus comes, phenyl migrates here, then here ketone, as you can see. Now one very interesting case we will look for. Just see, here you are having CH3CH, right, OH, and CH3 and phenyl, right, and here NH2. No, we have to make somewhat different. Here I have to take NH2, here I have to take OH, right? Now same reaction you are carrying out, Pinacol Pinacolone rearrangement, but this time you are using nitrous acid, right? So just see, loss of this NH2 from here going to give you 2 degree carbocation, and this one going to give you tertiary benzylic carbon. This is most stable, right? So H plus you will attack here, but this is not the case actually. Whenever you are looking NH2 there, H plus will always attack at this NH2, because diazonium salt is formed from NH2 only. From here diazonium salts cannot be formed. So irrespective of the nature of stability of carbocation, in this case H plus should always attack at NH2 group, right? So what will happen after the this NH2 will convert into N2Cl plus minus, this one, and loss of Cl via NaCl, and N2 live here C plus. So just see what the case comes here, CH positive charge, then CH3 phenyl and OH, right? See, this carbocation is less stable if the same carbocation would have been formed here, right? But because of this NH2 group, you have to attack H plus always here, not here. Getting? So in this case, it doesn't matter after the loss of NH2 we are getting the stable carbocation or not. But whenever we are having NH2, we should always attack here. Okay. Now HSO4 will come into the rescue operation. Oh no. Now migration will take place, na? Okay. Now migration will take place, and see the migrating aptitude. Phenyl will come here. So phenyl you have to bring at this carbon. So what you are having, CH3, CH, phenyl here, and CH3. By loss of this phenyl, positive charge appeared here, and when H plus is lost by HSO4 minus, a ketone will be there. Getting? A ketone will be there. See? Now after losing this one, the final product for this reaction, CH3, CH, phenyl, CH3 and doubly bonded O. Now this pinacolone will form in this case, right? I am just giving you some more problem for practice. If you want to the solution for those problem, comment. Definitely I will provide the solution, right? Let us have some question for practice, Now see, okay, 2 moles you will take MgHg hydrogen, it is going to form B. Now it is treated with H2SO4, it will give you C. This one problem for practice. Now see B. Okay. Now this one for you. By the same way, I am writing directly Hg, Mg, H2, then H2SO4, right? What the product will form here, you have to tell. Okay. Now in this case also, you have to tell the product. One OH here and one OH here. This is C. Okay. Same set of reagent. Actually in this one Pinacol is given, so here only H2SO4, dilute H2SO4 is required, because in these two cases Pinacol will form first, then you have to bring pinacolone. Here I have already given Pinacol, you have to convert it into pinacolone, right? Now listen, if you want to the solution for these problems, like, subscribe and comment if you want the solution. Thank you.